Welcome to the Graph Show. This is the second episode we're recording. The previous episode was with Jans Osman. Today I'm with Dr. Denise Gosnell, Chief Data Officer at DataStax. Denise has a new book out called The Practitioner's Guide to Graph Data with Matthias Broekler, published by O'Reilly not long ago. So the subtitle of the book is Applying Graph Thinking and Graph Technologies to Solve Complex Problems. So I was thinking maybe we could just talk a bit about graph thinking, about graph technologies, and about complex problems.
Absolutely. That sounds like a great discussion, Josh. Thank you.
Sure. So why don't you just tell everyone what graph thinking means?
What we mean by graph thinking is using the natural way that you express data in your mind and applying that to how you work with data in technology or in an application. So for an example, Josh, before we got to know each other through the graph community, we could have gone on LinkedIn and searched for each other. We probably would have seen a badge right there that said to, and that we had a mutual connection with Lynn Bender, most likely. And that's what graph thinking is. It's that we use applications and we navigate our lives every day through thinking in relationships, the context about ourselves and how we're connected to other individuals, other locations, or other events in the world. And graph technology is now giving us the ability to represent those relationships and use them in applications in meaningful ways, just like LinkedIn uses those badges to help you understand how you're connected to somebody else.
Sure, and that's a really interesting topic to me. I think we could go off on kind of a cognitive science tangent. What exactly does it mean to think in graphs? What are mental representations? Are they graph-like, and so on? But maybe, I know in your book you sort of contrast graph thinking with, say, the way that we think about relational databases. So how are graphs different from relational databases in terms of how you think about them?
Absolutely. And that's the place that everyone starts. Mainly because today, the technology most of us are familiar with for databases is relational technology, not to be confused with relationships in graph databases. But the primary difference from our perspective is thinking about data in rows and columns versus prioritizing and being more interested in the relationships that exist between points of data. That's at its core the difference in how you're using relational technology versus graph technology.
So what sort of things can you do with a graph data model that are maybe harder with a relational database or relational schema with the relational style of thinking?
That's a great question. And to be honest, no matter what world you're coming in, if you try hard enough, you can do anything in either system, right? So it just kind of comes down to skill and how long you want to spend building your application. But I think the first place to start to really begin to understand the differences between the systems is what is being called Customer 360, or the term that you have starting to coin, which I prefer as well, so we can put a little R next to Josh or a TM Josh, the X360 model. And from understanding that model, it's helpful to begin to look at the differences between relational technology and graph technology. So a little bit more about what we mean there, if that would work.
Yeah, sure.
So
go ahead.
Sorry. So the Customer 360 model, or the X360 model, is a great way to begin to look at how it would get implemented in a relational system versus a graph system. The idea of this is that you have data existing at your company or in your enterprise across many silos about a really critical entity. We'll go with the customer because that's what C360 stands for. And in your customer model, you have your customers maybe in one existing location. You have their purchases in another. You have their addresses, maybe their in-store visits, their online behaviors. They're typically stored in separate systems. And those who are very interested in getting started with graph databases want to start with just unifying a representation of your customer with relationships that point to their various data sources in the other system. When you're looking at what it takes to implement this in a relational system versus a graph system, that's a really, really great starting comparison. Let's start with even digging into the modeling as a first example. Typically, when people are comparing these systems, they think about data modeling, they think about queries, and they think maybe about system performance for this type of application. And when you're working with Customer 360, relational systems have been around a heck of a lot longer. They have decades, since the 1970s, of resources and documentation and examples. So across all of those, you're going to really see them win for getting up to speed quickly because you have so much more information out there. But where you start to see graph technologies really make a lot of gains is in that query section when you're comparing modeling, queries, and performance. For example, when I was working with some developers on implementing a Customer 360 system at a really large insurance company in the United States, they had this working using SQL, and they had maybe about 130 lines to do the basic for this customer, tell me everything about them. So you're one query. Yep, one query, about 120, 130 lines of SQL. And that's because of all the joins you had. Essentially, for every time you had a link over to the other system, you're joining to other tables. So it was an extremely long query. When we helped them migrate that over to a property graph database and using graph query languages, namely Gremlin, that query shortened to 18 lines. It's really hard to argue with it at that point. The code is so much shorter to maintain, but a different mindset to understand. So that was one of the major wins and one of the really early signals that we're starting to see on why technologists are really loving the pairing of graph databases with graph query languages.
I agree, and that's something we have at Uber as well. That's something I think that exists at every major company, is some sort of customer 360. And I see a lot of effort going into creating these 360 views for customers, and it's worth making that effort because it's an important asset. But you see, when you try to generalize that, so that's my term X360 is kind of okay. We have customer 360. Now we want to do this same thing for organizations, for vehicles, for different types of entities throughout the company, and you don't want to have to replicate that amount of effort for each type of entity that you want to derive these insights from. So I totally agree. That's where graphs can save a ton of effort and kind of allow you to generalize these patterns that you might have developed for a customer 360 to other things.
Absolutely.
So I kind of had a script here, but I think we're kind of going off the script anyway. In the book, you talk about a number of different access patterns, and one of them is kind of customer 360 and neighborhoods. And I think we could talk about how that relates to standardization. But you also had several other patterns, such as pathfinding. Maybe you'd like to speak about those.
Yeah, that's absolutely. And when Matthias and I have had the opportunity to work with hundreds of teams around the world, it became a theme that we wanted to help teach everyone else about these common templates we were observing as we have been helping implement different database and graph database applications. And the four most common templates that we have been helping with were Customer 360 or neighborhoods, hierarchical queries or trees, pathfinding like you mentioned, and then finally the recommendation systems or the collaborative filtering query that everyone usually talks about. So those are the four most common templates. Absolutely, there's a long tail of unique applications that are really fascinating. But if you're looking for a way to begin to drive value from the idea of using a graph database and picking a templated style of problem that's commonly solved, it's going to usually be one of those four. And those four were pretty much in descending order of popularity.
Can you speak a little bit more about what you mean by a template? So there are these different types of access patterns. What does having that template do for the potential user of graph technologies? What is that just a part of graph thinking, that there are certain patterns associated with Customer 360 and neighborhoods, with pathfinding, with recommendations, and so on. So what is included in that template?
So included in that template is schema on how you would model for that problem, business questions that are seeking value from graph-shaped data to answer a question using your schema. And then third, Gremlin queries on the schema using the properties that solve and answer the business question. Those are the three things that we included in those templates. And we went about writing and attempting to organize our experience around these four templates because we were commonly finding that people were very new to graph databases and graph technology. And they see that moment. And Josh, I'm sure you've had it many a times where you begin to realize that you can model your whole world like a graph. And it's so much closer to how we think humanly, and you then expressing it in an application or in a database. But all too often, I've seen the grand idea of let's model everything in a graph fall in the gap of lacking specificity to drive towards a specific business outcome. And I wanted to keep people from falling in that gap, which I fell in, which ultimately led to a project no longer being sponsored because you weren't helping to further your business. So these four templates help give specificity to what to try first when you're getting started with graph databases. And we already mentioned the value of Customer 360. It's where everyone's starting. You're going about the process of trying to identify who is who and what is what across all your data and unify it. The idea of doing hierarchical queries is also extremely common because most humans naturally organize themselves in some type of hierarchy. And you just probably want to know from the topmost part of the hierarchy, tell me all of the individuals as you crawl down the hierarchy, or you probably want to start at an individual and say, well, what's the topmost root? Those are some of the really common questions if you're thinking hierarchically that you need to know from your data. And we outline the same type of information for pathfinding and for recommendations as well. Start here, tell me the path to here, or if I give you this input, can you apply the collaborative filtering process to give me, say, X number of recommendations with some score threshold? Those are the common approaches people are taking with graph technology. And my recommendation always to new graph technologists, irrespective of what platform or vendor you're using, model your world, go for it. It's really fun, but make sure that you are driving towards one specific problem to get it all the way through to some type of end outcome, and it's likely going to be one of those four templates.
Sure. So that the templates are more specific than I thought, and they come with particular examples of Gremlin queries and so on. So I've skimmed your book, but I haven't read those sections yet. I look forward to doing that, and I can see how those will be helpful to people who are sort of kicking the tires on graph databases. So what back to Customer 360? What's an example of the Gremlin queries that you talk about in connection with Customer 360? I feel like I have a better handle on, say, pathfinding and recommendations.
Yeah, so for Customer 360, the common pattern is to start with a certain customer or organization or vehicle, like you were mentioning in your other type of 360 graphs. And typically you want to format the results with JSON of everything that is important or connected to that entity. So the Gremlin queries that we walk through show you how to use the project by patterns to format your payloads in an expected structure from your 360 graph with the necessary information. You can, most likely, there's going to be some type of requirement to say, for this customer, I want the most recent purchase or the most recent X information. And we show you how to filter on edges in that fashion and essentially teach you this JSON shape-driven query pattern process on using Gremlin, where project by is like one of my favorite patterns that I use all the time now for shaping JSON results.
Okay, you mentioned when we were chatting before, you mentioned the profile step and the explain step as well, and I think you were talking about those in connection with shortest paths. Do you want to go
Yes.
into some details on those?
Yes. I'm so glad you brought that up. I think that explain and profile are two of the most important and underutilized steps in the Gremlin query language that are out there. It's kind of like a call to action from my perspective for anyone who's involved in Gremlin. We could use so many more examples on how to use the information from these two steps to solve a data-oriented problem. So for shortest path, that was one example where I was really excited to get down into the weeds with Daniel Cuppets to truly understand how to apply it to the shortest path problem. So the example you're referencing is that we're doing shortest path in our book examples across the Bitcoin OTC network, where Bitcoin wallets are rating how much they trust other wallets. And so the fun problem was to say for these two wallets on the Bitcoin network who have never connected before, can you tell me how much they actually trust each other according to who else they trust? So it ends up being a path problem. And what you need to do in order to say confidently that the result is the single shortest path is to dive into the results of explain as you're doing your pathfinding queries and look to see whether or not you are using barriers. When you use barriers, potentially high explanation without going all the way into the functional programming streams of Gremlin, when you use barriers, it's forcing your single source shortest path query to do breadth first search. So when you combine having a barrier along with limiting to only the first result, that's how you're guaranteed to get the single shortest path when you're doing pathfinding in Gremlin. And when we were able to work with Daniel Cuppets and Steven and the language creators to put this together and synthesize it, it was this aha moment of how much knowledge is stored in profile and explain that the graph community is not tapping into. And I would love to see more examples out there about how to bring that information, how to surface it and apply it to really fascinating graph problems, where in our book we really go into the weeds on how it applies to single source shortest path.
Sure. Have you looked at, or in your book, did you go into details on searching from both ends? That's something we do at Uber. Pathfinding is hugely important in the risk and safety knowledge graph. We actually take both vertices and basically do a breadth first search from both ends until we meet in the middle, and that saves a bit of time.
Absolutely. I believe that is the fastest known solution to date. So we implemented A star starting from one vertex and ending at the other. And what you're saying and calling out is absolutely true. If you implement A star alternatingly from each of the endpoints, that is going to divide your search space and computation time in half, and ultimately be the fastest way. So no, we didn't implement that in the book. We did not do bidirectional search. But if there's a reader who would like to submit that, hey Josh, maybe we can work on that in the next version of that chapter.
Sure. Well, on the topic of sort of the future of Gremlin, where would you like to see the language go in the next, say, 1 year, 5 years, 10 years, along with sort of the future of graph technology, if you want to go that broad over the next few years?
Yeah, so that's a great question, and I know there's some brilliant technologists out there who have started playing with this because we've been talking about it, but I would love to see it become much more widely used. And it is it's a bridge between learning Gremlin and how we intuitively think about our data visually. Mm-hmm. Specifically, I would love to see Gremlin come out with an improved, notebook-like experience. I'm sure someone's already working on it, where you're able to look at your schema and you can essentially trace through your schema and then it write your Gremlin query. So some of the beginning is really easy. If you start at a certain vertex and do a walk of ins and outs, that part isn't too difficult to create. But when you want to do a little bit of recursion, or you want to do single source shortest path and then fine tune your filters and things like that, it's a little bit harder and more complicated to visually represent that and then see your Gremlin query happen. But a lot of the innovation that I would love to support and be a part of is any innovation that begins to bridge the gap at the highest level on how people so intuitively represent their data like a graph in some type of visualization, and then mapping it down into some type of generated technology, be it a Gremlin query or a schema. I would love to see those initiatives come to light.
Sure. So you talk about something called GSL, or the Graph Schema Language, in the book. Do you want to give us some details about GSL?
Yeah. So GSL is the GSL, or the Graph Schema Language, is our first proposal on how to create an ERD, the entity relationship diagrams for relational technology, to start to standardize how you are going to share schema architectural diagrams around an organization. It's pretty simple. A lot of graph theory and graph databases already is extremely visual when you begin to talk about vertices and edges. But we wanted to start to standardize on how you represent your edges, because that's where it actually gets really hairy. When you think about an edge in the graph world, all edges already start conceptually at a many-to-many style connection. At the schema level, a one-to-many edge doesn't exactly make sense. So what you're really thinking about when you're thinking through your data modeling, you're thinking about the multiplicity of an edge in your data. And the multiplicity is going to have two options. It's going to either be a set or a collection. When your edge is a set, it means that your connection from, say, a customer to a bank account is going to have, only, a unique list of bank accounts. So your ownership only can be, at that level, a person can own one bank account. But if your edges are a collection, you can have multiple ways in which you own that bank account. So you could be
with additional metadata on the edges and things.
Absolutely, you got it. So at the schema level, it starts many to many, and we needed a visual way to represent, following multiplicity, how we would illustrate if it's going to be a set or a collection. And that really is what the GSL starts to dive into and attempt to use throughout the rest of the book's examples. I'd love to know what the community thinks, and I know that you have some other initiatives also working on GQL, I believe. And so I would love to see a little bit more standardization around property graphs so that we can more uniformly adopt these at different companies.
Yeah, so for those who don't know what GQL is, that's an ISO, an attempt to develop a new ISO standard for graph schemas and graph queries. It's the graph query language. It's sort of still in the early stages, but so there are various working groups who are working on things like, what is the basic data model for a standard graph query language or a standard graph schema language? What sort of constraints do you need in the language? How do you express things like multiplicity and so on? So it'll be very interesting to see where that standardization effort ends up. I think we really need to balance expressivity with simplicity. One of the strengths of SQL and the relational model is that it's very simple, and I think that's one of the factors that has allowed it to become, as ubiquitous as it is. So we need more of that from graphs as well. Do you think there are any things that may be holding graphs back from achieving the sort of breadth that relational databases have achieved? Is there anything that's kind of still to be solved that's holding us back?
Absolutely. And Josh, I think you just named it, in my opinion. The way that you can use SQL to query relational databases is so simple. We think very naturally in graphs, and we can understand our world in graphs. It's how we all think as humans. But I do think that now the bar for using graph technology is extremely high. It's really difficult to use. And we honestly, at the end of the day, we are talking about bringing forth NPC or, really, really difficult, like the most difficult problems in computer science are now at your fingertips to solve. So, there is going to be a trade-off that is bound by the laws of physics on how quickly you can solve some of these problems. But I am really looking forward to a lot of the initiatives that are out there trying to standardize and make languages easier to use around graph databases, because I do think that that is one of the adoption bars that is keeping more people from picking them up.
Yeah, and I think it's interesting, graphs being so intuitive, as you say, and then the standards around graphs, particularly things like RDF, which are great for data integration, but are very complex, and that complexity has been kind of a barrier to entry for a lot of developers.
Absolutely.
So, well, I don't want to take too much time. Thank you very much for talking with us, Denise.
Of course, Josh.
This will be, like I said, episode number 2 for the Graph Show. We'll be recording more interviews like this. Go ahead and subscribe to datageeks.tv. And with that, again, thanks, Denise, and I'll see you around the Graphscape.
Awesome. Thanks, Josh.